Okay, so let's review first. Again, our Maclaurin series is the function of x is equal to summation of x raised to the n power over n factorial multiplied by f of n of 0 from n is equal to 0 all the way to infinity. So basically, in our Taylor series, as I said last time, the Maclaurin series is special representation of Taylor series at x is equal to 0. But if there's a value of x, so if there's a value of x, so therefore, our Taylor series is f of x, which is summation of x minus, so let's represent first a, which is centered at x, raised to the n power over n factorial multiplied by f of n, so which is not equal to 0, so therefore f of n of a from n is equal to 0 all the way to infinity. Okay, let's have an example of Taylor series. Find a Taylor series for the function of f of x is equal to ln of x at centered a is equal to 1. Okay, since in our Taylor series, we need of course the derivative of a function, let's try to solve first the derivative of ln of x. So if f of x is equal to ln of x, so to find of course f prime of x, or the first derivative of ln of x, this one is equal to 1 over x. Okay? How about the second derivative of 1 over x? So 1 over x is equal to x raised to negative 1. So therefore, this one is negative x raised to negative 2, or just simply what? Negative 1 over x squared. Okay. How about the third derivative? We have f derivative of negative 1 over x squared is what? So basically, we have 2 x to the negative 3, or just simply 2 over x cubed. How about the fourth derivative? Fourth derivative of x, which is negative 3 times 2, is negative 6, x raised to negative 4, or just simply negative 6 over x raised to the fourth power. Okay? So since we have of course f of a, okay, we have to find of course f of 1, which is ln of 0 is equal to 0. F prime of 1, what is f prime of 1? 1 over 1 is equal to 1. How about the second derivative? f2 of 1. f2 of 1 is equal to negative 1. You just simply negative 1 over 1. How about the third derivative? f3 of 1. f3 of 1 is equal to 2. 2 over 1. And then finally, f of 4 of 1 is equal to negative 6 over 1, which is negative 6. Okay, again, the formal definition of Taylor series. We have, of course, f of x is equal to the summation of x minus a raised to the n power over n factorial multiplied, of course, by fn of a from 0 to infinity. Okay, so if you want to expand that one, f of x is equal to, if n is equal to 0, so therefore x minus a raised to 0 is 1. So therefore we have f of a plus, if n is equal to 0, so therefore 1. If n is equal to 1, we have x minus a raised to the first power over 1 factorial is still x minus a multiplied by f prime of a plus, if n is equal to 2, so we have of course x minus a quantity to the second power over 2 factorial multiplied by f2 of a plus x minus a n is equal to 3 over 3 factorial multiplied by f 3 of a plus, if n is equal to 4, so therefore we have x minus a raised to the 4th power over 4 factorial multiplied by f4 of a plus, and so on and so forth. So basically, substituting f of 1, f prime of 1, second derivative, third derivative, at centered a is equal to 1. So therefore, ln of x is equal to f of 1, which is 0, plus, what is the value of x minus a? X minus a meaning, we have of course x minus 1 quantity raised to the first power multiplied by f prime of a, which is f prime of 1. What is f prime of 1? Multiplied by 1 plus, we have x minus a, which is a is equal to 1, quantity to the second power, over 2 factorial, f2 of prime is equal to negative 1 plus x minus 3, x minus 1 raised to the third power over 3 factorial. What is f3 prime of 1? So this one is multiplied by 2 plus x minus 1 quantity to the fourth power over 4 factorial multiplied by negative 6. Okay, there you go. So let's try to evaluate all the functions. So let's have ln of x. So therefore we have 0 plus x minus 1 raised to the 1 is still x minus 1. X minus 1 quantity squared times negative 1. So therefore we have minus x minus 1 quantity squared over 2 factorial. This one is 2 multiplied by 2, so plus 2 multiplied by x minus 1, plus 2 multiplied by x minus 1 raised to the third power over 3 factorial minus, this one is 6 multiplied by x minus 1 raised to the fourth power over 4 factorial. So therefore, ln of x is equal to x minus 1, again, raised to the first power over 1, minus x minus 1 raised to the second power over 2 factorial, which is 2, plus 2 multiplied by x minus 1 raised to the third power over 3 factorial is 3 times 2 times 1. So therefore, we have to cancel this one. Minus 6 raised to x minus 1 raised to the fourth power over 4 times 3 times 2 times 1. So therefore, 3 times 2 is equal to 6. So we have to cancel 6. So finally, ln of x is equal to x minus 1 raised to the first power over 1 minus x minus 1 quantity to the second power over 2 plus x minus 1 raised to the third power over 3 minus 6 multiplied by x minus 1 raised to the fourth power over 4. Okay? So simplifying that one into a summation form, ln of x is equal to summation of, so let's start with n is equal to 0. N is equal to 0 and we're going to infinity. Okay, so when n is equal to 0, we need to get 1 as an exponent. When n is equal to 1, we need to get 2. And when n is equal to 2, we need to get 3, and so on and so forth. So therefore, there is always 1 more than our n value. So what we're going to do is we have to get n plus 1. So this is gonna be x minus 1 raised to n plus 1. Okay, why? Again, if n is equal to 0, 0 plus 1 is equal to 1. If n is equal to 1, 1 plus 1, our exponent is positive 2. Okay? So since the number at the bottom is the same, so 1 and then of course 1, 2 and then of course 2, 3 and then of course 3. Okay? So we need to have an n plus 1 expression on the bottom. So therefore we have of course an n plus 1. Okay? So now, the last thing we need to deal are the alternating sign. So we have here the positive, negative, positive, and then of course the negative. Okay? So we can use negative 1 raised to the n power. Okay? So for the alternating one. So again, if n is equal to 0, any number raised to 0 is always equal to 1. So therefore, negative 1 raised to 0 is equal to 1. So therefore, this is positive. If n is equal to 1, so negative 1 raised to positive 1, so negative 1. So we can use, of course, negative 1 raised to the n power. So we have to append this one into negative 1 raised to the n power. So finally, I will just simply rewrite the function of x, which is ln of x, is equal to summation of negative 1 raised to the n power multiplied by x minus 1 raised to n plus 1 all over n plus 1 from n is equal to 0 all the way to infinity. So that is actually the expression for ln of x using, of course, the Taylor series expansion.